Monsieur Miller. Yeah, they just do. Okay, so it's 10 o'clock, so let's get, we need a minute taker and a jabber scribe. We have a jabber. Thank you, Joe, for volunteering so early. Minute taker, major decisions. We don't need a blow by blow.
Everyone who's sitting in the back, we got plenty of room up here, so come on up.
I feel like
That's you, Deb. Come on.
I feel like we picked on somebody else last time, so I don't know if I want to pick on the same person this time. Anybody? Anybody want to get famous? Anybody? We can't start unless we get a minute taker. Awkward silence. Do 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 do. Minutes. Anybody want to take minutes? Anybody? Anybody? That'd be excellent. A bad job is better than no job. That's Felix. Thank you very much, Felix. I appreciate it. I got a banana if you want one. Sorry. Yeah, it's mostly just the actions. You don't need the like play-by-play what the discussion was. If people, we really need that, we can get that back from the recording. So welcome, MLS IETF 106. I'm Sean.
I'm Nick. Hello.
And Catriel is not here, but he might be remotely. And Brendan's in the Meet Echo. All right. So this is the note. Well, it's Friday morning. You should have seen this a lot, unless you only came for today. Basically, you know, behave. What you say at the microphone is going to be recorded. If you're aware of IPR, you need to disclose it, that kind of stuff. You can click on the links to get more detailed information. Pretty straightforward. So we got a minute taker, we got a jabber scribe. The blue sheets are going around, so please sign those. When you get to the microphone, please make sure to state your name, and let's keep it professional at the mic. Our agenda is, progress since the last interim, open issues, and future items. We do actually have a fair number of slides, though it's only 2 presentations. So I guess we're going to start off with Richard. And let me switch over to the next presentation. Check.
Test. Feels a little silly being up here literally on a pedestal in front of this crowd. So what I was going to cover is kind of some changes we've made since the last interim. So this is going to be the stuff that went into draft 08, which have been stuff we were largely discussing off and on before then, but this is kind of your notification that has landed and last chance to complain about it. There are.
You can't read it. Kind of bad is a kind of an understatement. Just saying. That might be all right.
Is that color all right? All right. Well, that is the only transition, only for transition. So if the chairs want to take a 3-minute break, I can change this and get them to do that. Yeah. Okay.
Do we want to open up the set of issues just to just open up GitHub and we can just kind of give people an overview of the status of things. Okay, so we're going to just load up GitHub right now and give some folks just a high-level overview of what issues are open, and these are things we'll be addressing later. Felix is taking notes. Okay, so we have 16 open issues, 66 closed. Some of these are very old. This is just on the protocol document. Here are the 11 issues that are open on the architecture document. The hope is that some of these will be resolved pretty quickly. They've been around for a while.
Right, you're done? Because I have a link, so I can download it and upload it.
Richard has used his Sharpie to draw on white paper this time. Is it dash 202, 01, I mean?
So all right, apologies for too much innovation there. The game went too far. So yeah, so section 1 is stuff that went into draft 08. Section 2 is going to be things I screwed up in draft 08 that I discovered on the plane on the way over here. And then we'll have some future-y looking stuff. So the one like big change to dwarf all other changes is proposal commit stuff. I think we've been talking about this for a full meeting cycle. We had a bunch of discussion at the interim about this. But the basic idea is that instead of having adds, updates, removes, each initiate a new epoch. Now we have these proposals which get sent out to the group to propose a change, but that change doesn't actually get put into effect until someone sends a commit message. So you can basically lazily add people or lazily update people, and they're not actually added or updated or removed until someone sends a commit. The idea is to amortize the cost of updates in groups that are quiescent. So you only have to send commit messages when you're actually going to do something with the group. So if you know there's a requirement in there that if you have seen some proposals come in while you've been quiescent, and then you're going to send a message, you need to send a commit before you send a message, so that when any actual activity occurs within the group, all those proposals get committed and put into effect before there's an actual encryption. This obviously can be made to revert back to the previous scheme if you always send a commit alongside a proposal. So it just adds the additional flexibility, you know, usual an extra layer of indirection, adds that flexibility so that you can amortize cost in groups that are maybe lower activity. Raphael, do you have anything you want to add on this? Because this has been one of your favorite things. Okay, so this was fairly invasive change in document terms, but I think is mostly works. You know, implementation is just starting to kind of verify everything holds together. And we found a couple of you know, technical nits in how it holds together, but I think that's overall the message. Now, one thing for people to keep in mind is that proposals that are not committed cause the tree to degrade. So here we've updated 2 leaves and added someone in the second leaf. And they degrade the tree in the sense that these X'd out nodes, they cause these X'd out nodes to be blank. So when you do a change to a leaf, all the proposals right now change the leaf and blank the path above that leaf. And what that means is that when the next person updates, they'll have to encrypt individually to the leaf nodes that have been added or updated. So you don't get the benefit of having the tree there. You don't get the performance benefit because all of these nodes are blank in the middle as a result of proposals that haven't been committed. When you rebuild is when you do commits. So here we've had the first leftmost node do a commit, which has repopulated those nodes on its path to the root. So, there's this trade-off here between amortization and, things, when you impose the cost and the cost of the thing when you finally do it. Yeah, Archery.
It's terrible. I should fix this. So, but there's no way. So when you say there's no way to reject a proposal, right?
So one of the areas where we should probably start, where we need more clarity as a follow-on to the technical changes, is exactly what the policy is around what the policy considerations are for how proposals are accepted or rejected. So right now, in technical terms, it is up to the sender of the commit message to decide what proposals go into that commit.
So I can subset them?
Yes.
And, so what happens, if I propose 1, 2, 3, and 4, and then someone commits 4, 3, 2, and 1 in the opposite order?
So proposals themselves are not ordered until they are committed. So the committer also decides the order in which proposals are applied. So what this does is it takes what were previously like ordering problems that would have to be enforced on the group and makes the committer the arbiter of those ordering things.
So, I mean, I guess it's been a long time since I've looked at this in any detail, but have you convinced yourself that that works?
Works in what sense?
Well, I mean, in that it used to, I mean, I guess for TreeCam, this is less serious. I mean, so TreeCam allowed simultaneous updates, that was the premise of TreeCam, right? But some things in TreeCam could not be sequenced that way. It could not simultaneous. And so,
TreeCam in principle allowed simultaneous updates.
Yeah, no, I understand. I guess I'm just trying to make sure that my memory of the situation was that some things could not be some things depend on other things, and some updates depend on other updates, right? And so how do those? So
part of what it took to make the proposals thing make the ordering independence work is that an update now is more limited than an update in the prior sense. So an update does not get you PCS. An update plus someone else committing gets you PCS.
Okay.
So the semantics have changed a little bit in addition to the ordering of things.
Okay. I'm thinking about this a little. This seems a little hard. So you're saying that if I offer 1, 2, 3, and 4, and then you pick up 2, 3, and 4, and I'm like, what the hell happened to 1? Then I can just commit 1.
Exactly. And if you really want things to happen in a certain way, you can commit them yourself.
Why would you not want things to happen in a certain way? I mean,
I think Raphael might have a little better answer as to motivation.
Yeah, happy to take that. So, because it doesn't matter in that sense. So what changes now is that you can group the proposals by category, meaning you first deal with the removes, because what that does, it only blanks the leaf and the direct path for a certain member. And so that destroys the tree to some extent. And then once you've done that, I don't remember, you do the adds and then the updates, or
I think you do updates and then removes and then adds.
Well, at the end of the day, so what you do with the updates, you only really now change the leaf node. Mm-hmm. You don't do the direct path anymore. So it doesn't have any effect on anybody else when you change the leaf. And for deletes, you just delete stuff, the leaf, and then whatever is above it, and the same is for add. And really only the commit is going to change any of the intermediary nodes.
Okay, but now I have a different question, which is, say that I propose 1, 2, 3, and 4, and Raphael commits 2 and 4, and Colin commits 3 and 4.
So proposals each proposal is premised on a given epoch, so a given starting point.
No, I understand, but I guess so what happens? I mean, how do you know anybody can commit, right? Is part of your thesis, right?
Yeah.
And so, what if 2 people try to commit? There's one of them wins the race, and everyone loses.
So commits have the same ordering criterion as we had before. So before we had this proposal, this criterion that any group operation, any change to the group, had to be sequenced so that you have linear history. Here we have the same requirement, but it applies only to commits.
Okay, great. So why would someone else commit or not commit?
So you would commit because you're required to before you send a message.
Okay. So, all right.
Yeah.
There's a bit of a question. Okay, go ahead, Raphael.
Yeah, that answers it. So you're not allowed to send an application message if there's some pending proposals. You have to commit first. And so the whole idea here is that you don't have to do it immediately if there's nothing going on in the group. So you can sort of pay the cost later. The whole thing was driven by the problem that we had a bottleneck whenever in a multi-device scenario, somebody would add a device to their account, and all of a sudden they would have to do crypto in hundreds of groups, most of which are effectively dead because people created them at some point and then they never use them again. So it seemed very expensive to do some crypto in those groups. So with this proposal commit scheme, you can decide to do it later or not do it at all. That's then up to the application to decide.
I mean, this seems like a very worthy objective. I'm just trying to make sure it works. But no, I mean, like, I understand what you're talking about, and it seems like extremely like a really good idea to try to make that work. And I'm just trying to make sure that, like, I understand the subtleties of why it would work or not work.
Yeah, the minimum is you have to commit before you send messages. I think there's probably going to be advantages to scheduling commits at an application layer. For example, when you add someone, you probably want them to update and commit that update so that their path to the root gets populated and you have a fuller tree. Yeah.
Calvin from Google. So this may have an odd pathology if we have read receipts. So if somebody sends a message and a proposal at the same time, then everyone in the group will try to receive that message. And so we get everyone trying to commit the same proposal at the same time. I'm not entirely sure how to solve this here, but it could be required, for instance, if someone tries to remove themselves and send a message or something like that.
Sorry, could you state again what you think the challenge is?
If like everyone tries to commit the proposal at the same time, it could generate a ton of commits at the same time. So it's odd to see.
Yeah, so there's going to be an inherent contention issue with this protocol just because we have common group state. And so those contentions are going to have to get resolved by the application somehow, whether that's at commit time or before this PR, we had that for any change you made to the group. So yeah, I think there's more work to be done in terms of figuring out how this integrates with applications.
Yeah,
and read receipts and multi-packaging especially.
Yeah. And like ordering is generally a problem we haven't solved yet.
Yeah. And I think part of the reason this seemed appealing is because it punts the ordering to more infrequent events.
Yeah, it solves a lot of problems. Just this is an odd pathology that we found.
Rio Kazuara from Lepidum. I have a clarifying question. If the committer is the arbiter, like the ordering is communicated through commit messages to other nodes, is that correct?
That's correct. Yeah.
Like so like how are like the proposals are committed in communicated to other nodes in like another form of message. Also correct?
Yeah. So the presumption here is that the members of the group have received the proposals being committed and cached them.
Okay.
And then the commit includes kind of indexes into that cache.
Okay. And also like another comment about like ordering, like the ordering problem, I think it will still happen for the ordering of the commits. So So I think this proposal and commit solves the ordering of the proposals, but I think there's still the problem of ordering the commits between other nodes and stuff.
Yeah, so no matter what we do here,
Yeah.
we're going to have a problem either of ordering or of dealing with forked histories.
Oh yeah, okay, thank you.
And we have a little bit of touch. We touched briefly on forked histories in a little bit, but that's generally we assume that things are kept pretty linear. Okay, so not hearing any like dramatic pain, we're going to keep this. I'm not going to plan to revert that PR. There's a couple of nice implications that fall out of that. Can I have some water, please? So one of the cool implications that falls out of proposals is that with proposals, you can have multiple new clients added to a group in the same epoch, which is one level a little challenging because before each time you added someone, you had to send them a welcome message. So adding multiple people sounds like more work. But because you're initiating all these people into the same epoch, that means now you can send them all pretty much the same thing. There's like one secret that varies, this path secret that varies per node, but everything else that you're going to tell them about the group is going to be the same. And so you can just send one thing encrypted under a common key. The big thing is this group info. That's going to be it's going to have size on the scale of the size of the group. And then you send what we call a key package to each individual client that's joined that lets them decrypt the big encrypted thing. So that in itself is just kind of a nice little optimization. But what I think makes this extra nice is that we had before this separation between welcome message, which add a single individual new participant to the group, and init messages, where you would add multiple people to the group all at once to initialize a group. I think what's nice about this framework is that now this looks very much, because this is designed to be sent to multiple people at once, you have now made something that can be used both as a welcome message to welcome new members to a running group and something that can be used to welcome the initial set of participants to the group. So there's now a much cleaner group creation algorithm in the document where the creator makes a one-member group of a very specific form. We've defined all the initial parameters. The creator then effectively sends itself the add proposals to add the initial set of participants. Now, obviously, this can be done virtually and optimized out because it's not visible to the external world. But then commits that, which is, I think, exactly the same computation, entails exactly the same computations we were doing with init before, but can be expressed more cleanly with this proposals language. So once the creator has done those additions, it gets out a new state for itself and a welcome message that it can send to all of the new members at once. It's the same message that goes to everybody, and they just select the key package that belongs to them. So we've added a little bit of complexity here with this kind of two-stage encryption, but I think it's a net win in terms of complexity because we've gone from init and welcome down to one single thing, and we've cleaned up the creation stage. Any questions, comments about this approach? Okay. Like I said, I'm kind of considering it's kind of last call for complaints. Another kind of neat implication about proposals, and Calvin, your comment about self-remove reminds me that's another thing. So before any change to the group had to be proposed from inside of the group, because a change to the group came with, in the case of update and remove, it caused encryption of new entropy to the group, and we didn't want to allow that from outside. But right now, proposals, the stuff that goes in proposals, an add proposal just says add this client init key, just provides the client init key. There's no secret change to the group. You don't do anything secret with the group until you send a commit. So this means that people outside of the group are now capable of generating proposals that the group can evaluate and decide whether to accept or not. And the only question here is how do you verify it? And what landed in the document is that we signal how you verify it by the signer ID, which is in most cases an index into the group, but we've reserved this chunk of very large numbers to address these special cases. Yeah, Calvin.
So is there any reason to use this special numbers? Calvin Rowland from Google. Maybe using these special numbers rather than just indicating via like a field or something that I'm doing something for not in the group.
No reason except, compactness of syntax. If you had a separate field, it would be there and it would cost you a few more bytes, but I don't think it's probably a huge consideration. If you wanted to gen up a PR to tease out this signaling, I think we could probably do that.
Okay.
Yeah.
So so I understood FFFF, et cetera, that I get. I don't quite understand the pre-configured ones.
Yeah, so the pre-configured ones, the assumption is so that's designed for like you have an application where there's some server in control, and the clients are configured somehow out of band to know to trust that server.
Right.
And so the idea is that you have some table of 0 to 255 elements that maps sender IDs to the public keys you use to verify.
Okay, so I can't believe I'm bike shedding this, but that if you're going to make a range for this, let's make it bigger. You got a lot of space.
Sure. Or following Calvin's idea, maybe we just we generalize the sender identifier, and we either have.
Also be fine. I'm just saying like that. You got 2 to 32 bits. You're gonna be really sad when you want 257, and you're like, well, what the hell? So like make yourself 65,000 or something.
I mean, maybe you're more pessimistic about the size of the groups we're going to have here, but we're not going to be able to fit half of the world's population if we.
I see. Okay, so I see. You're turning this back on me. Your point is we're going to have like 2 to the 32. Like the real problem is we're going to have 2 to the 32 minus minus 65,000, and that's where and that green sad we'd have like another like 30,000 like entries. Yeah, that's like I'm very concerned with that.
Future's bigger than the past, man. Yeah, so I think that would totally be a sensible proposal to clean up the signaling a little bit. I think we'd probably want to have kind of abstract the kind of signer type. So we would have within the group external externally configured, so basically servers, and then the joiner itself for the user initiated add case. Now I mentioned this gets yeah.
So this means that like the server can just sign as the client needs to know some sort of server identity, so the server can sign as well.
Yeah, that's the assumption. Yeah, like I said, the assumption is the clients are configured with some table that maps from these IDs to the public keys you use to verify. Yep. Now the bottom call out here mentions that this gives us almost gives us server initiated add. This obviously gives us server initiated remove because the server just proposes the remove into the group. This doesn't quite give us server initiated add. So it gives us the server's ability to propose the add that will then be realized when someone in the group commits. But in that interim, so that means because of this commit before send requirement, that means that the new joiner will get any messages that are sent by existing participants before once they send them. But the new joiner can't immediately send to the group. So there's a missing send to group thing, which I think Raphael is going to talk about in his slides later. We kind of treated that as a separate send to group from outside function to do as a follow-on. So yeah, great. So action item to Calvin here to propose the update there. There was some concern at the interim, so now this is getting away a little bit from the proposal stuff. There's some concern at the interim about downgrade protection. So Brendan had proposed that we simplify the client init key structs by having them be specific to a version and a cipher suite. Now, the working model here is that client init keys are stored by some server and they're provided to a client when it wants to initiate a group. And so there's this downgrade worry that if Raphael's client supports 2 really crappy legacy suites and 2 really awesome new suites, he'll have provisioned 4 client init keys, and the server can choose to send me the old crappy legacy suites and prevent me from having a conversation with him using the new suites. So to address that, we added extensions to client init keys. So this is something we kind of seemed like we needed anyway. We're kind of following the TLS pattern here by having the client init keys express what versions they support of the protocol and what cipher suites they support. So the key that's in the client init key is still going to be specific to a cipher suite, but the idea is that when you are creating a group, you download a bunch of client init keys, you see what suites you got, and you can look at these supported cipher suites array and verify that what you got was the best thing that was supported.
I think maybe I'm misunderstanding this design. So each client init key is going to duplicate all this information.
Yes. It duplicates the support information.
David Benjamin in the house. I mean, why not just have one bundle that has everything in it?
Brendan is on the mic. Brendan's in the Meet Echo. I think he had proposed this change. I'm forgetting exactly what the rationale was beyond just streamlining the objects. Raphael, maybe he remembers.
I think the idea is that you can rotate them. If you put everything into one key, then you have to throw away all the cipher suites, even if you haven't consumed them, in order to get fresh client init keys. It's doable, but it's a lot of waste.
I'm not sure I'm processing that, but I'm happy to think about it later. I guess, so I think one, I mean, is the idea that I'm supposed to, so I'm supposed to, like the way I consume this thing is I take the thing and then I like negotiate the best version and then I pull the key out, right? So what happens if MLS version, MLS version 1 does not support post-quantum, and MLS version 2 does, and I want post-quantum, so I pull out, so I happen to get the client init key that has X25519 but not post-quantum in it, and now I version negotiate, and now like I look at the key and I'm like, oops.
You're saying there's potential conflict between the versions and cipher negotiations?
Yeah. Whereas if you have them in one bundle, then you can do sequential ordering one at a time, and each decision you make narrows down the remaining decisions.
So Brendan McMillan in the Jabber says, because there's a lot of keys, then it'll be a big CIK. Imagine supporting ECC and RSA. Even if you use ECC, you'd always have to send RSA, and everybody would have to store it.
Maybe. Okay. Well, I'll take another look. But I think I think the problem is you now need to explain how the negotiation works, and why isn't that allow downgrade? So so imagine the case I just indicated, right, where we have version 1 which only supports classical, and version 2 which supports post-quantum and classical, right? And so the version negotiation is just fine. But then the server removes so they both say I support 1 and 2, and there's two CIKs, one of which says they both say 1 and 2, and one has 2519, the other one has 2519X psych, right? And what I do is I remove the second one, and so now I have forced you in an error posture, which is one possibility, or I've still forced you back down to the classical, right? So I'm not entirely sure so depending on how you define this, so I'm not sure the error posture is acceptable, and the second one seems like it's a downgrade. So I think I think the first step is to write down what the algorithm that you're supposed to execute is as a client.
Like that sounded like a downgrade attack, in which case an error seems like the right outcome.
I mean, maybe. I guess are the semantics that but then you're placing some strong semantics and you're requiring all the CIKs can never get lost. That's the posture.
Sorry, can you slow that
You're
down?
saying CIKs can never get lost. That's the posture. Like there's no subsetting is an attack.
I think that would be the implication of this algorithm. Yeah.
Okay. Then I'm not quite.
I agree. Has interesting operational.
Then I'm not quite sure what the resources being conserved here is, because it seems like I still have to download all the CIKs anyway.
Maybe we should add that the term downgrade protection is a little ambitious here. This sort of helps to detect, potential downgrade. It doesn't guarantee that no downgrade can ever occur.
Calvin, so the set of supported cipher suites and versions is more of a property of the client and not really the property of the key. So it's odd to see like their supported cipher suites be included in every single client in a key you get from that client. Would it make more sense to perhaps specify that you can specify your support versions to the client in a key server, and then you can just query what versions the client supports?
Yeah, I mean, we could split this out into a separate information element effectively.
Yeah.
Like it would have to be signed by the client clearly so that it's authentic. Yeah, I think the idea here was we had kind of there's existing operational practice around managing these init keys, and so this using the init key as the struct to hold this stuff avoided creating another thing to manage.
Mhm.
But if it's a big enough problem, we can obviously add a new struct.
Yeah.
I agree that it's a little awkward jamming it in here.
It's also awkward to see a required extension that like, might as well just put in the main message then. Why have the extension?
Yeah. Don't have real strong feelings about that. I think my feeling here is so this expiration thing is an example. I think the feeling was we're going to have a need for things that are optional and some need for extensibility here. And so these are things that are extensions in TLS, and so might as well exercise the extensibility mechanism that we're going to need anyway.
Sounds good.
Yeah, so since I mentioned expiration, right, another thing you could do to Ecker's point is if you've got a client that supports crappy suites and they upgrade to support awesome suites and publish new client init keys, one thing the server could do is just ignore the new ones and keep around the old ones, and give everyone the old keys and force you to only use the legacy suites. So, in addition to other concerns about ensuring freshness and rotating client init keys, this expiration is just like super simple uint32 or uint64 second since epoch sort of thing to specify expiry.
So I think actually what Raphael said was like pretty important, which is like defining what this is supposed to do. Really helpful. I mean, so if you recall, like we spent quite a while in TLS, and there's like an enormous appendix that is like allegedly tells you what like the security guarantees of TLS are supposed to be. Yeah. And so it seems like maybe we should start by defining what security guarantees of this are supposed to be, and then we'll know if it achieves them or not.
Yeah. And since Berdush is not here, I will propose that he write that section.
Sure. If you want to assign me to that, I'll try to give it a shot.
Oh, okay, great. Thanks.
Didn't you just propose I write it? Is that,
No, I proposed Berdush write it.
Oh, well, that's even better. Oh, fantastic. Like, I don't want to like do any work. I'm happy to, if you think I should, I'm happy to give it a shot, but I don't think I'm probably the best person to do it.
I mean, since you're thinking about it now, like if you wanted to jot down like a list of properties that you think sounds like about the right set, and we could iterate on, that would be helpful if you could send that to the
Yeah, I could do that if you don't mind, just to keep it on my list. If you don't mind assigning me the GitHub issue.
Can chairs, some combination of chairs and note takers make sure that we get around to that? Okay, thanks. Cool. All right, so that's extensibility. What next? Okay, so we landed a whole bunch of things last week and published a draft. Monday? We had some trouble with the draft tracker deadline. And on the flight over here, I tried to implement it, and I came across some bugs. Well, this was actually just an improvement. So one of the things, the version of the welcomes in draft 8, since we have this separated encryption thing, the keys that were used to encrypt the group info were just generated by the sender of it, which was kind of unfortunate in terms in that it requires the sender to have fresh entropy, and you're assuming that the key generation goes okay. It occurred to me that because we are in an epoch already, we can just KDF more stuff off the epoch secret and use that for encrypting welcome messages. It keeps things a little bit more hermetic. The other thing is in the handshake messages, in the commit messages, we have this confirmation. We've had it in group operations before, which existing members of the group use to confirm that they've all arrived at the same state as a result of processing this group operation or commit message. This is analogous to the finished Mac in TLS that confirms that the two ends saw the same transcript. It turns out we have all the material in the welcome message that that the new joiner would need to be able to compute that confirmation. So we might as well, my thinking here is we might as well throw it in the welcome message so that the recipient, the new joiner, after it's imported all this stuff and done some of the key derivations, can verify that it has arrived at the same state as at least the sender of the message. It won't know that it's in the same state as the rest of the group, but it will get kind of an internal consistency check on it that it has correctly processed the welcome message. So I don't think we really get any meaningful security properties out of this, but it seems like a useful, sanity check, probably, a way of avoiding bugs in implementation with fairly low cost. So there's a PR for this. I think it's a fairly small change. Kind of inclined to land it as a way to make things a little bit more internally, a little bit more rigid. So minor stuff, no comments. Okay. The other thing is proposal IDs, as in draft 8, don't actually work. As we just said before, the commits have to have pointers to which proposals they're implementing. One of the changes we made in the proposals PR fairly late in the game was to make the hash in the proposal ID the hash of the MLS plaintext that contains the proposal. And then I landed a PR after that enabled MLS plaintext contain multiple proposals. So now we have this ambiguity of which of these proposals does this refer to. This is kind of an instance of a slightly more general problem. So Calvin and Nimad pointed this out, that we have right now this packing of multiple proposals in a commit into a single MLS plaintext, which introduces this ambiguity about how you refer to proposals, introduces a little bit of complexity into the processing and key selection, et cetera. So there's this kind of general question of like, how do we pack things into MLS plaintexts? So the trade-off here is, on the one hand, if we pack stuff in, as we do, as we kind of do now, as you could do slightly more generically, then you can use a single signature operation to cover a bunch of stuff. So if I'm adding 20 new people to the group and sending 5 messages alongside them, I can sign all of that stuff together at once and not have to do 25 signatures. So it's some computation savings. But on the other hand, if I do all that packing, then my unpacking code gets a lot more complex. And we have this question that was raised, that I think Imad raised one-on-one to me about whether we, well, if you're going to do key separation, you have to change which key you use based on what is encrypted in the message, whether it's a handshake message like a commit or a proposal, or whether it's application content. And if you're not going to do that key switching, then you have this question of whether you've lost something in terms of key separation. So wanted to open this question up actually for discussion as whether people have feelings about which of these should be a priority in terms of amortizing signatures or maintaining a stronger key separation. Obviously, the kind of simplest solution with highest clearest key separation would be this middle proposal, where each MLS plaintext contains exactly one thing. It either contains a single application message, a single proposal, or a single commit. So you have a clear semantic for what each MLS plaintext is, and you have that kind of unit there. But that means you have to do a separate signature for each of those, which you don't if you do this kind of packing thing. So, like, people have thoughts on trade-offs here? All right, Calvin, I see you kind of gesturing.
I slightly lean towards just the simple solution, just use one entry for everything, because might as well just keep it simple. Like, I'm not really sure the implication of using separate keys are for the same key for a signature over different plain text. Feels weird.
Yeah.
Slight thing. I like generic framing also looks sort of nice, but I don't really have an opinion either way.
Yeah, I think I agree that the current frame, I'm sorry, what was that? Jonathan?
Okay, basically, like, I don't really have an opinion either way. Like, one entry seems slightly nicer because it keeps the code simple. And we don't actually know how much, like, I don't have a good idea how much a signature actually costs on most clients.
Yeah, I agree that the current solution is kind of pessimal in that it is like neither clear nor simple. So I think unless people object and unless people are worried about doing bazillions of signatures, I think I kind of agree with Calvin that the single entry one is going to be simpler to reason about. And we can do that for now. And if it gets to be a computational burden later, we can look into optimizing. Does that, generally seem plausible to people? Seeing a couple nods. Yeah. Okay. All right, cool. Another thing I tried to slip in right before the deadline, I thought I was going to get agreement from my co-authors, and it turns out we didn't agree, was this question of making epochs unpredictable. So right now, the epoch, which identifies all your crypto state in MLS, that epoch is just a counter. You start at epoch 0, the next epoch is 1, the next epoch after that is 2, and you go straight forward. And you have to have linear history as a result because you have no way to refer, you have no way to identify to different forks if you have them. This forking property, it turns out, is important for some applications. So the matrix protocol, which has been looking at integrating MLS, operates in a fairly highly decentralized mode, and so they have common forks and merges of history. I'm not proposing to address the merge question, which is much more complicated, but the only barrier to doing the fork half of that now is this epoch question. So the idea here would be to just make the epoch something unpredictable. So it still needs to be a unique identifier for the state of the group over time. But instead of assuring that via having a linear counter, we would assure it, sort of stochastically. You generate you derive some value off the key schedule that would become the identifier for the epoch. Raphael, I think you had the concerns about this.
Yeah, I did have some concerns. I wasn't quite sure if the server could actually do its job of enforcing the ordering of commit messages. I don't have a strong argument right now, and this might just work. But to be honest, I have to think about it some more.
Okay, and so to be clear about why I think that's not a problem, the rule the server needs to commit to enforce is that there are no two commits on the same. So if the server is going to enforce linear history, we're going to not tolerate forks, then what the server needs to enforce is that there are no two commits on the same epoch. And the outside of the envelope of the MLS ciphertext will state what epoch this is premised on. And so the server can see, even if that's a random epoch, that there are no two that are identical. So I think Jonathan, let us get the mic. So I think it seems to me that it's pretty likely you could still still do that job. Yeah.
Jonathan Lennox, I mean, with only 32 bits, you will get collisions occasionally. Do you have a procedure for that?
Well, so that's kind of the question. I've illustrated 32 bits here. You could obviously make them 32 bytes. I think immediately after I posted this, Brendan submitted a comment on the PR. It was like, stop truncating hashes. So I'm inclined to truncate a little bit here, just because this is going to be sent in every message, and it seems kind of bloaty to send a 32-byte hash in every message. But I agree that we do need to have it be large enough to make collisions pretty rare. I'm not super worried about collisions because the space of collisions is not every epoch ever. I think in practice, you're going to be worried about collisions in the set of states that clients have around. You're going to want to delete state for forward secrecy. And so clients might have a handful of states around in cache, and it's only if you have a collision in that recent history that there's an issue. So maybe it's not that big an issue.
Jonathan Hoyland, Cloudflare. If you did have a collision of two blocks that were very close to each other, is there some way you expect clients to be able to recover, or is just the whole group burned?
Haven't gotten there yet.
I think that would actually be pretty bad.
Yeah.
That's why I was also concerned about the collision thing, because if you derive this epoch ID from the key schedule, unless you get some new freshness into your key schedule, then it is a problem. I mean, you could detect that on the client side as you generate a new epoch. You could see, oh, this looks like the old one. I better do a new commit.
I mean, you could
But,
just
yeah.
add freshness. Like when you commit, you have to insert a nonce into an HKDF extract, and then use the HKDF expand to like generate your batch of commits.
Yeah, now that I say it out loud, I think you always have some new freshness in a commit message anyway, because at the very least you do an update of your own leaf key.
Yeah,
So
no,
that
you
would
always have
probably
freshness
work,
in a
yes.
commit message.
And I mean, do we also need to worry about, if you've got freshness coming in, do we need to worry about some malicious group member searching for very quickly through the 32-bit key space and saying, here's another commit that has the same hash, and trying to fork the state without anyone noticing that the state has been forked because they both have the same
So
ID.
the server should catch that. I mean, the server should see that there is a collision. So we still
Are we
rely
talking
on
about decentralized apps here, supporting decentralized apps?
Okay, then I don't know how that would work.
Yeah. So it's a fair question. I think I'm not too worried about people trying to effectively reverse the epoch ID and kind of brute force to achieve specific values, because each attempt at one of those would require several public key operations. So it's fairly expensive to generate a fresh guess at an epoch ID if it's generated like this.
So you just have to worry about the entire state being destroyed by somebody finding one by accident.
Yeah, I think so. Which, I mean, it seems like if you use enough bits, it can be extraordinary. It can be pretty unlikely. Okay. So I think we can probably continue go a couple rounds on the list on this, but I think I'm net inclined to take the risk, and we can have some discussion about how to write down the security properties around this on the list. All right, so Raphael, I think you're up now.
Yeah, I wanted to give a brief overview of the open questions we still have after draft 8 that we have to address in the next weeks and months. And there's the 3 of them that are really worth looking into. Thanks. So the first one is a relatively big one. And so this is an extension to TreeCam that has been proposed by a number of people, Joel, Sandro, Evgeny, and Yanis. And they published a paper. If you click on that URL, once the slides are published, you can read the whole paper. So I'm not intimately familiar with how it works exactly. And so what you're about to see is probably just a gross oversimplification of how it works. So the assumption is that the threat model that is being considered for our TreeCam is slightly different from the one from TreeCam. So there's nothing new to see here. This is essentially what TreeCam is addressing in terms of threat modeling. So if you assume that Alice gets compromised at some point by having all of her local state being copied to the attacker, essentially, the attacker can impersonate Alice up until the point that Alice does an update, and therefore successfully evicts the attacker. If the attacker doesn't have any access to Alice's storage anymore, Alice will have introduced some freshness with the update, and that excludes the attacker from being part of the group. And so this is what we call post-compromise security. And before the point of the attack, we have forward security, and that simply means that the attacker cannot get their hands on key material that would be useful to decrypt things that were sent before the time of the attack. So in Archery cam, the threat model is a little larger in the sense that the assumption is that an attacker can potentially compromise more than one member. Since in MLS everything is about a group, it makes sense to think about these more complex models as well. So if we have the same scenario in the beginning where Alice gets compromised at first, and later she's going to send the same update, but at a much later point in time, Bob, which is an arbitrary other member in the group, gets compromised as well. So in the worst case scenario, where we would assume that Bob has been a passive member, meaning that Bob has been consuming messages sent to the group, but has never issued any update on his own. In that particular case, compromising Bob will dramatically increase the size of the window of compromise. And so the reason for that is that when Alice issues an update, she's going to cam some secret to one of the nodes in Bob's direct path. In the worst case, they're siblings, and then she's going to cam it to Bob directly. And if Bob has not issued an update in all that time, that means that Bob still has the keys stored locally in his local storage to decrypt that chemmed update from Alice. So that means that when Bob gets compromised, we can sort of recover the freshness that Alice introduced. And since the attacker had everything before Alice introduced that freshness, the attacker now has absolutely everything from the point where Alice got compromised to the point where Bob gets compromised. So this looks pretty dramatic, but I want to emphasize that this is the absolute worst case. And this is not guaranteed to work all the time. So even if Bob doesn't update, if Alice and Bob are sufficiently far away from each other in the binary tree, then it's very likely that those values will have been overwritten by somebody else's update. This is just to illustrate how compromising two separate members can give you more than just the sum of those two windows of compromise. So, yeah, this is what I already said, actually. These are the ingredients for the worst case scenario, basically. Alice and Bob are siblings, are very close to each other in the tree. Alice gets compromised very early on. Bob is a passive member and only gets compromised towards the end of the lifetime of the group, or at the very least at a much later point in time. So this leads to a scenario where, at the very least, the confidentiality of the group is broken. And so there's been some dispute whether this is now forward secrecy or post-compromise security that is broken. I've heard the term PCFS, post-compromise forward secrecy. It actually doesn't matter what we call it. The confidentiality is broken for quite a bit if we run into this worst case. On average, the window of compromise gets a little bigger if you consider the attacker to be able to attack more than one member, but it doesn't dramatically increase necessarily. And also what's very important is the assumption here that Bob is a passive member. Normally, Bob should not be a passive member. Everybody should issue updates once in a while. In small groups, that works really well. The problem is in really large groups. If say you have a group of 10,000 members, if everybody issues an update once a day, that's a lot of updates to process for other members. It's just some crypto to do in the background. It doesn't give you anything other than security properties. So the the assumption here is that in larger groups, it might just be the case that applications decide not to issue as many updates anymore. Since it's not mandated to issue updates regularly with MLS, it's up to the application to decide when to issue them. And well, people tend to go for whatever is cheapest in terms of computational effort and payload. So the assumption is there won't be updates all the time. So how does Archery work? The idea behind is that we can do Diffie-Hellman with some deltas. That scheme, I think, is called UPKE. So imagine that Alice has a key pair, a secret and a public one. And now Bob chooses a delta and encrypts this delta under the public key of Alice and sends it to Alice. What Bob can now do with UPKE, it's some sort of homomorphic property where Bob can calculate a new public key that is essentially the secret key plus the delta and advertise that without needing any response from Alice. And Alice can do the same on her side. So in practice, what that means, so this is a tree where the rightmost leaf does an update. And the green, I don't know if you can see the colors well. So the green pluses here just indicate that there is some new freshness on the direct path all the way to the root. And that's how it is today with MLS. With ArcheryChem, we get some additional freshness on the co-path, which is the siblings of the direct path nodes. So you have the blue pluses here that now also get some freshness. So, and this is important because these are the nodes that the green freshness is being chemmed to. So as a passive member, if you consume that, you're going to throw away whatever old values you had in there before. So try to come up with a list of pros and cons. Obviously, it does make sense to think about an extended threat model because we talk about groups. Things are being improved if members are passive, but we also need to be very clear that this is not an incentive for members to be passive, because if you're passive, you still don't have any PCS if you get compromised. So you still should do updates. This doesn't avoid that scenario at all. It comes with a little overhead that seems tolerable, but it's still an overhead. And so last night the question was brought up how this compares to other messaging protocols, actually. And it's kind of hard to compare because we think in terms of groups now. And there aren't that many other protocols that take care of groups. So sender keys, for example, doesn't even compare because sender keys doesn't have any sort of post-compromise security. If you get compromised as a member with sender keys, then you are not going to recover from that at all, actually, until you start generating some new freshness, which normally you only do when somebody got evicted from the group. So that might be a long time or never, actually. And with pairwise encryption, like with plain signal protocol, for example, again, there is no notion of groups. So groups are done in a way that you have this n-1 legs between you and the rest of the groups. And these sessions, these individual sessions, are not cryptographically correlated at all. So if you attack several members in a group, then you cannot immediately combine these windows of compromise because things are completely distinct. However, it might be the case that these one-to-one connections are also passive. So Signal gives you post-compromise security if you do Diffie-Hellman ratcheting on these sessions. But if you imagine that two members are part of the same group but don't exchange anything between each other, ever. It could very well be that one of them is absolutely passive. If they're not connected otherwise and exchange messages. So this might still work very well in signal groups as well. So bottom line is it's hard to compare. It's not better or worse than others. It just works differently. So on the list of cons, that one is a little longer. So first of all, UPKE is not standard cryptography. So we are talking about the multiplication of two private keys here. So this is something relatively new that has not been studied in academia a lot. It's not nothing complicated. It's not very hard to analyze either, but it's new. So if you're wondering whether there's a mustache here, some people have called this hipster crypto because it's new and hip, but we don't know if it's fit for purpose. And in the particular case of Curve 25519, there are some concerns about the security level because private keys are clamped, and then you would clamp them before you multiply them, and then the question is what your security level is afterwards. And a very practical consideration is that none of the standard crypto libraries would support this. So you would have to essentially roll your own in addition to whatever crypto library you're using. So it's especially bad with web crypto because then you don't have any support whatsoever. I'm not even sure you can manipulate private keys with web crypto easily. So for an IETF standard, this is quite a concern actually, that it's not quite clear to implementers what to do here. And I mentioned that already, there is an increase in the payload. It seems tolerable, but it's still an increase. So this is still an open question. There's been quite a bit of discussion on the mailing list, and the practical problem here is simply time. So if this is something we want to adopt, this is going to be an issue time-wise.
And by time, you mean working through getting the analysis and getting it into the libraries and stuff? Okay.
Exactly, yes. Richard, you want to add something?
Yeah, so I was just going to inject my analysis and opinion here. I think your pros and cons list is about right. I'm not sure this would result in increased payload size. I think you may just be able to get away with deriving some extra stuff and folding that in. But again, that would require more analysis. My general inclination here is to punt on this for now and not add it to the spec, probably in the initial version we do. I think this might be doable as an extension or as a V1. I'm thinking about some of the extensions we made to TLS, proposed to TLS 1.3 to kind of update the key schedule with new stuff. I think you could envision this as an analogous extension to MLS if once we finish the initial version and assuming the relevant prerequisites firm up. I think the hipster crypto aspect of this is concerning for me. I don't think we have a firm enough grasp on what this update operation entails and what the bounds are on its usability, especially in the Curve 2509 and Curve 448 case. I'm pleased that the proposers here have actually worked out how to do it. Like when we first looked at this, it wasn't clear that it was even possible to do updating like this on 25519 and 448. We have now some proof that it is in fact possible with a couple of caveats. But I don't feel like we have a strong enough understanding of what the implications of that are to be comfortable adding this to the spec. So my proposal is we kind of basically choose to punt on this for now.
Okay. Any other questions?
Just to conclude, I do think that what it provides is valuable. I think the increase for PCFS, as it's called, is a valuable extra property, but I don't think it's one we can't live without. And so I feel comfortable punting.
Yeah, I tend to agree with that. I mean, it's not like MLS is catastrophically bad without that. It's still very good, but this would make it a little better. We just have to be very careful not to introduce any new risks because of the new crypto.
I mean, so the idea is like, if this is good and better and we could get it in V2, right? Would the idea be that we would kick all this other process off to get this reviewed and put in other libraries to get ready to use for V2? Or do you think it would just kind of stop?
No, I mean, that could be ongoing work.
Okay.
Depends on how dedicated people are. Any other questions, comments? So I'm going to jump to another subject. This one's going to be very brief. We talked about that in the past, and I just wanted to give you a little overview of where we stand, which is pretty much still in the same place as last time. So when you add a new member to a group, whether that is actually a new user or a new client, you have to transfer some state. Some of it is secret, and that goes into the welcome message. And some of it is the public keys in the tree, which are not particularly secret because they're public keys. And finally, also the roster, meaning the list of members in a group. So we have three ways of doing it, fundamentally. One is the one that is in the protocol right now, and that is client to client, meaning everything goes into the welcome message. It's end-to-end encrypted, so it's secure and private. You cannot really look into it. The problem is it doesn't scale very well. So if you have a very large group, you get a huge welcome message. And also, if you are a member of many groups and then you add a device, then you need to transfer the state for those many groups to the new device. So this is also a scalability problem. So very early on, one of the intuitions was that we need the server to assist with that somehow. And one way of doing it, of course, is to store the public keys of the tree on the server, and also to store the roster on the server, meaning who's a member of the group. So the public keys of the tree is probably not too bad, because they're just public keys. They don't say a lot as such. I mean, they don't really help identifying people, etc. They could maybe be used for some more elaborate attacks. Having the roster on the server is not great, on the other hand. It's a privacy concern. So this is obviously the worst solution in terms of privacy. And so ever since, the idea was born that maybe we can encrypt this stuff as well. And so this is something we want to look into in the next weeks and months, because we don't have a very good proposal for that yet. So we are talking about metadata encryption. So if it doesn't have all the security properties that we apply to messages, for example, that might be fine. But we need some good initial proposal. So this is still an open question as such.
So I guess you're being really nice. I'll try to make this a little more pointed. Is there anybody that wants to stand up and talk for doing client to client for this? Because I mean, it works well in small environments, but some of the environments we're talking about are like 10,000. So
this is Richard. I'm standing up because this is the logistically simplest, and what I think probably merits running to ground is whether there's with the recent, especially with the recent simplifications to the welcome message, where you're sending one large thing to welcome everybody. I'm not sure that seems pretty close to like the theoretical lower bound on how much data you'd have to send. So I'm fine investigating some alternative strategies here, but I wonder if there is actually much to be gained here.
Well, I'm hoping that we can go from 3 to at least 2, because I think 2 is just, I think 2 is like a non-starter. So if anybody wants to get up and start talking about that one, well, it'll get interesting.
It's Calvin. One use case that's pretty useful for transferring state is when the client loses its state and starts failing to decrypt stuff. And so you have to, like, the current solution, just remove and add. That feels kind of like we could just get the state back somehow better. Would be nice.
Yeah, I mean, you just addressed another problem actually. Clients losing state, so at the very least they have to get the state back. Yeah.
Yeah, so I think maybe to revise my previous remarks, I think maybe this is not exactly the right axis to slice this on. Like, you're going to have the initiating, or you're going to have clients upload something that the server holds on to and redistributes. I think so. I think the question we need to investigate here is, like, what does the client need to update and under what circumstances, and what the server need to hold on to. I think that kind of covers all three of these cases, and we can answer those questions. So
yeah, I mean, that's correct. I mean, transferring means the client is uploading it to a server, most likely, because we're not in a peer-to-peer scenario necessarily, and then another client downloading it. So the idea for servers is that the uploading still happens, but it happens ahead of time, alongside other messages. So that when we're in the scenario where a client needs to download everything, that client can do that without having to wait for another client to upload something first. All right, if there are no further questions. Richard already mentioned it earlier on. This has been a long-standing idea to send things to a group from an external party. So the external party, the assumption here, of course, is that that party doesn't have access to any of the group secrets, yet can still encrypt in a way that only members of the group can then decrypt it. So there are some different use cases for that, just to motivate the idea as such. For example, the server can encrypt things like status messages that are application specific to the group, and that way those messages don't have to stay on the server unencrypted until they're consumed. So in that case, it's more like metadata protection, essentially. Another use case that I think is going to be very important, and that is when external users are being invited to the group. Richard mentioned it already, that this might be a proposal from the server, for example, and that proposal has not yet been committed, yet the invitation has already been sent out. So the new user or the new client thinks that they will soon be part of the group. They don't receive any messages because there's no activity in the group, but maybe they would like to send some messages already, and then they could do that with that mechanism. Yeah, there's a question.
So there's, Calvin, just two things here. If two users, so one of the use cases here is for external user who hasn't yet joined the group, be able to send messages to the group. So this means they can send and they'll be able to receive with commits, but they won't be able to receive messages from another user in the same state as another user who hasn't yet joined the group. So if two people try to join the group, they're not quite added yet, and they both send messages, they won't get each other's messages.
Yeah, that's a very good point, yeah.
And secondly, if a user has proposed to be removed but hasn't been removed yet, they'll be able to get these messages as well.
Sorry, can you repeat that last one?
If the user has been proposed to be removed, but that remove hasn't been committed yet, they'll be able to get these external messages as well, because these external users not going to commit the remove before sending a message.
Yeah, I think so. I think the user would still get those. But I mean, the user doesn't appear as being removed yet, at least to the external user.
Yes.
So, I mean, it's maybe not what you want, but at least it would be transparent.
Yeah.
But it's a very good point, yeah. We can obviously come up with some more rules around that. This is a relatively simple approach for now. And another use case would be handshake messages. So when the server does a proposal for an add or remove, we can simply also just encrypt that to the group. Again, this is in the context of protecting that metadata, essentially. Then, of course, we already hinted at the fact that whether or not a commit will be consumed or accepted, whether proposals will make it into the commit, that will depend on the particular policy that the application will apply. So in practical terms, this is certainly not the final version, but just to give you an idea, in the key schedule, we can simply derive a secret, a sent from outside secret, and we can take that secret to generate or to derive a key pair, and then we can just use HPKE with that. So on the last struct, we have an ephemeral HPKE public key that is used, and then the message is simply just encrypted as an HPKE ciphertext. So note that there is no authentication here. So this is an open question as well, whether or in what way we want this to be authenticated. Because obviously, if a member of the group receives that, they don't know who sent it. Could be anyone. So yeah, that is an open question. If it is an external user, for example, that is about to become a real member, then we actually have some identity key material that we could use for a signature. If it is something that is sent by the server, then we might not have that because the server is not signing stuff. So the most general case here for me would be to say this should be some sort of more proprietary format inside the ciphertext.
This is Richard Barnes again. So I think the first chunk of this is totally sensible. I think, yeah, so the first two chunks, deriving something off the key schedule and then deriving a key pair off that, obvious. I think you have actually two authentication problems, not just one. Mm-hmm. You have the problem of authenticating who is sending to the group, but you also have the problem authenticating whether a key belongs to a group for the sender. Now, I think that's probably not an issue that we're going to solve in the protocol. I think that's probably something to cover in the architecture, in that basically as an additional function of the authentication services. We've posited an authentication service that vouches for bindings between user identities and public keys. I think what is needed to make this really hold together is an additional function on that authentication service to vouch for bindings between group identities and public keys. So I think we just need to describe that in order to have that full story there. As far as the sender authentication, my inclination here would be to reuse the MLS plaintext structure. And so you would have a signed message with same sort of contents, either application messages or proposals. And basically treat this as, I think if you do that, all you really have to do is provide a credential alongside that in the wrapping. So you'd have kind of an alternative MLS ciphertext thing. So right now MLS ciphertext is a symmetric encrypted MLS plaintext. So you'd have like MLS asymmetric ciphertext or something like that, where you would have, as you have here, the HPKE ciphertext, but probably also the credential that goes with that. And so that you can, so that the members of the group can verify from whom this message was sent.
Right. Yeah. So to address the two things you said, with the authentication of the group towards the external sender, that's a very interesting question. We have to see what sort of guarantees we can give there, because obviously the external party doesn't know anything about the group, and we'll get that from a party that is mostly untrusted, probably the server. So we have to see what meaningful guarantees we can have that are immediately applicable and not only in hindsight once a member has actually joined the group, because that might just be too late. And the other one regarding the signature, yeah, I thought about that as well. So obviously we don't want to have the signature out in the clear. We want that to be part of some ciphertext, or inside some ciphertext. The other thing is that the signature might just be optional, simply because there are scenarios where you don't want that because your server doesn't sign stuff. We could make that mandatory, of course, but
so in that case, what I'm concerned about in the case of when you say server doesn't sign stuff is when the group receives a proposal to say add someone, that purports to be from the server, how do they verify that they should accept that proposal?
Yeah, I mean, that is an open question. How you generally deal with proposals coming from the server. They could be signed, but I mean, the signing key lives on the server as well. So I agree with you that it doesn't sound good that when things are not signed, particularly in the context of add and remove.
So let me maybe ask the question a little differently. Do you think that requiring servers to sign proposals into the group would cause operational problems or deployment problems, or do you think we might just not quite get the properties you would expect out of it?
No, it's only for practical reasons. But I mean, you might be right. Maybe we should just enforce that.
Yeah.
It's not so complicated to generate some key material. The only thing is that we need to make sure that clients actually trust that. So we run into the typical certificate problems there.
Yeah, I actually think this cleans up the problem that Calvin noted with the current hacky system of signaling, reserving some code points and signaling external stuff that way. Because if the message from outside contains a credential and is signed, now you don't have to pre-configure all of the public keys into the clients. You can configure some identity authorities key and configure the clients to trust servers with certificates issued by that identity authority. So it makes the signaling a lot cleaner.
Yeah, that's probably the way to go.
But, with those modifications, I think this is a good thing to do.
Oh yeah, and one thing, I think Benjamin mentioned it last night regarding the derivation of the key pair. Potentially, we could derive more than one key pair for a given epoch. I'm not entirely sure what that solves, but it's definitely a possibility. In the same way we do it with the exporter for the key schedule. Yeah, I think that was the last slide. Any more questions? All right, thank you.
I have one more question. Are you going to make a PR for this?
I knew you were going to ask that, of course.
Okay. Hi, I'm Benjamin Berdouche. Can we get aligned here? Yeah. So this is a couple more future-y issues that Benjamin and I have been noodling on. So going to try and outline issues here. Maybe there's like a expand to fill screen. Yeah, that one. There we go. Sorry. Oh, okay. It's the opposite of what I would have expected. So a couple of things that we have, some of which we've got PRs on, can try and outline the proposals and get any feedback on solutions here. So first thing is this Mls Exporter thing. Those of you who have worked with TLS in the past know that it has an exporter function, so you can export keys out of it and layer things on top. I think the core of MLS is really the key exchange. We have a way of framing and sending application data messages, but I think it was always been pretty well understood that in a lot of cases you're going to want to export keys and use them for some non-MLS applications. So all this says is, much like in TLS, you take your epoch secret, there's an epoch secret at the top of this chain here, and in addition to deriving your application secrets, your confirmation MAC key, you derive an exporter secret that you're going to use for exporting. Yeah, similar. This PR is basically just a copy and paste from TLS. So same, you export your root exporter secret, and then you export specific secrets off of it. Thank you, Jonathan.
I was waiting for you to get up.
Jonathan Hoyland, Cloudflare. So if you want to have exporter secrets and also to be in line with RFC 5056, which says if you have exporter secrets, you must have importer secrets, then you should also have importer secrets.
I have that in a couple slides, so stay close to the mic. So that's the exporter stuff. It's probably just going to be pretty straightforward copy paste from TLS. That'll probably land pretty soon. Any other comments on exporters? Anyone who loves exporters? Like, I think this is critical. Yeah, that's more like it. Okay, good. So we're going to do this. So this is a little bit more complicated. This kind of gets to the security properties we get out of the protocol. So Karthik Bhargavan and Benjamin Verdouche have been looking at developing proofs of the security properties of this overall protocol. And one of the questions is, what assurances does a new member of the group get when he joins? Right now, all the new member gets when he joins is a welcome message signed by the person who is adding him to the group that says, behold, here is the state of the group. And there's credentials in the leaves of the tree that adder provides that say who occupies each of those leaves in the tree. But there's no signatures to say that the corresponding HBKE public keys actually belong to those users, or that any of the intermediate keys in the tree belong to the users below them in the tree. So whoever adds you to a group can completely lie to you about who is in the group, and you have no way to check that you've been lied to. So in order to counter this, you need to have some assurance that the keys in the tree actually follow this tree invariant that we've been talking about, that the private key for a node in the tree is known only to the nodes below it. And the approach that Benjamin and Karthik have come up with is to add some signatures to the tree. So the idea is that whenever you do an update, let's see, I've got some figures here. Whenever you do an update, you sign the nodes that you're updating in the tree. So when you're updating, you always provide new values for the nodes above you in the tree. So the proposal here is basically to augment that update and the resulting tree data structures to have those signatures over the nodes you are updating. So there's a couple of ways you could envision going about doing this. This is these presentations always start, presume a tree. So here we are presuming a 6-member group where the members are in the leaves, and everyone has updated in left to right order. So you can see A updated and reset all those things on its direct path, and B updated and overwrote that parent node, et cetera, all the way to the right. So this is how it works now. We don't have any signatures here. These are just public keys in these nodes. So one way you could go about implementing this is, I should have used colors or letters or something on these, but one way you could implement this is to attach signatures to each node. I guess the way to interpret this is that the gold circle on each of these means that there's a signature there over the public key in the node by the letter holder. So D double prime there is signed by D. So everything was signed by the last member that changed that node. So option number 1, carry re-sign the node every time you change it. Option number 2 is kind of syntactically different. The idea here is when you issue an update, you update your leaf with a list of the nodes you changed, and you sign that leaf. So here, D, when they updated nodes D, D prime, D double prime, and D triple prime. Now you notice that D triple prime, which was at the root, got overwritten. So that's kind of a useless hash that will never get used to verify. But in any case, your algorithm here is when you're checking whether a given node is valid, instead of verifying a signature on that node by one of its children, you check that it is in the signed list of one of its children. You get the same cryptographic assurances out of this. It's just a direct signature on the node versus a signature over a list, including the node. It's kind of a manifest approach. The idea of doing that is that you trade off message size for signing operations. So if you're going to sign all the nodes, that means whenever you do an update, in addition to doing log tree operation, DH operations, you have to do log signatures as well. But the benefit is that you only have a signature per node in the tree to keep track of. If you do the signature on leaves thing, you only have one signature, you just sign the leaf. but then you have to carry around nlogn hash values. Yeah, Jonathan.
Jonathan, thanks. Yeah, I think I don't understand the threat model because it seems like if the person adding you to the group is malicious, what stops them from basically impersonating the entire group? You know, it's a dial M for murder attack. Everybody you're talking to is actually the attacker.
So we have some protection against that in that we have we presume an authentication service that provides credentials. So there is at base some presumption that, you know, I can't imitate Jonathan@gmail.com because there's an authentication service that blocks me from doing that.
Jonathan Hoyden, Cloudflare. Could you do something fancy with batch signatures such that you only have to do one signature to cover all of the nodes in your path?
Yes, you may be able to do something like even simpler and more Merkle-y, not Merkle, more Bloom filtery. So then instead of having log n individual hash values, you could have a smaller Bloom filter and check inclusion in that Bloom filter for the nodes above it. So yeah, you could potentially optimize down the size.
I was trying to optimize for number of SIGOPs. Because if you could get yourself down to one signing option for option 1, then obviously that would be the benefit to option 2 and of option 1.
Yeah. So if you've got suggestions for algorithms to do that could be employed there, I think kind of going back to Raphael's presentation, we're keen to avoid exotic crypto here. But if there's some stuff that works more or less off the shelf, I agree that seems like it could, you know, cut through the trade-offs here. So, I mean, again, this is one of these cases where we've got a computation message size trade-off. I think my bias here is probably to do the one signature option and just carry the hashes around because it seems slightly simpler. But I'm looking at other implementers here to see what they think would be easier to do.
Yeah, just to add my 2 cents to that, I think what's important here is that conceptually this is a very important addition to the whole thing because MLS is one of the few protocols, or maybe the only one, that caters about groups. This makes a lot of sense because with one-to-one protocols, you don't have the concept of a group. You don't really know who is in the group. You only know it when you individually encrypt it to what you think are the recipients, but you never have any guarantee that when you receive a message, who the sender of that message, you know, was thinking is in the group. So this conceptually makes a lot of sense to do that addition for MLS. But I'm equally worried about the overhead here. So it would be interesting if we can make it even smaller. But if anything, I tend to agree with you that we should go with the one signature and more hashes because I think signatures are not pretty if you have a lot of them.
Calvin, any thoughts here? So there's another implementer. Whatever. But I think Raphael, to take your key point here was that option 3 is not the way to go. We should in fact address this risk in the most efficient way we can. Okay. All right, so I think the authors can plan on doing, I think, number 2 here. You sign the leaf and you just hash the nodes above and do inclusion checks. Jonathan, I'd be glad to hear if you've got some ideas for how to do better. Okay, that's that issue. This Benjamin added to the deck, and it was totally new to me. So I'm gonna kind of wing this. So right now, all of our injection of fresh entropy is via these HPKE things. One could imagine a post-quantum world where you want to inject some external entropy into the key schedule. So here's where we're getting to your importer stuff, Jonathan. So it appears, this is, I haven't even looked at the pull request for this. So it appears that the proposal here is to be able to add some additional entropy, some pre-shared key that the group has established using some out-of-band protocol to enhance the secrecy of the handshake. If we have less confidence in the DH or chem primitives that are being used for the HPKE distribution. So yeah, it sounds like, yeah, so he's talking about defining a new group operation that that says, take this PSK that I've identified and inject it into the key schedule. So I probably would be analogous to a commit message in that it would advance the epoch because you'd be advancing the key schedule. But instead of sending new entropy to the group in the form of you know, a bunch of HPKE stuff that updates the tree, you would just send things via this PSK input that is externally negotiated somehow. And yeah, I cited Jonathan's draft here. Jonathan, do you have any thoughts on this general approach? Whether there's things we could copy and paste from TLS, which is my favorite way of doing protocol engineering?
No, I think this looks good. Some thought needs to be given to checking whether you're actually. So in the extended key schedule draft, there's two different ways of injecting secrets, and they're not the same. So I'd need to spend some time thinking about which one you want here and which one you have here.
Yeah. Do you think it might be better to think of this as like a generic entropy importer, kind of in the style of stuff you proposed for TLS, as opposed to specifically a PSK authentication sort of thing?
Yeah. So because what you're in the TLS thing, at least, you're not actually trying to get a PSK necessarily, or you might be trying to layer MLS on top of some other protocol. So like if I was running MLS over the top of point-to-point TLS for some reason, I you know, I'm trying to come up with standing on one foot. I think you need some way of injecting a pre-shared key, but also some like agreed upon context, and that would be a channel binding. And yeah, I'd have to think about it.
Oh, so you're thinking that if we had a generic importer mechanism that could be used for injecting PSK-like stuff as well as injecting binding information.
Yeah. So you need a way of adding public information that you're committing to and secret information that you're agreeing upon.
Okay. All right. Yeah. Anyway, case it sounds like a little bit more discussion of motivations is in order. So I'll get Benjamin to send some mails to the list and get some discussion started. Because I don't really understand what this is trying to get to. It sounds like, but I think this importer approach is probably the way to go. Learning from the TLS experience. Let's see. Is this? Yeah. So. One of the things we've been discussing for a little while is how to deal with there's been a bit of a gap in our forward secrecy story, in our post-compromise security story, in that we assume there's no mechanism right now for doing any rotation of the signing keys that are used to identify participants. So if a client is compromised and they get really all of the secrets that are in there, including all of the DH keys and all of the signing keys, we have no way to recover from that because there's no way to rotate signing keys right now. So there's going to be a need for signature key rotation. I think Owen sent some mail to the list on this, starting up that conversation. I think as a first step toward that is replacing the current unsigned data in the leaves of the tree with client init keys. That's nice from one perspective because it kind of solves the problem we were just discussing about where to put the signatures over the parent nodes in the tree. So client init keys are signed, and client init keys have extensions now, so you can just make an extension that says, here are my parent nodes, and now you have the tree signing done. This also kind of opens the door to doing signature key rotation, because now when you do an update, instead of just saying, here's a fresh DH public key, you would probably, the implication of this is probably that you provide a fresh client init key, that it has a new DH key, potentially a new signing key, and other information. Yeah, Raphael.
Yeah, that's an interesting idea. I just wonder how that's going to work with what we discussed 10 minutes ago with signing the intermediate leaves if you rotate the signature keys, because the signature of the intermediate leaves are going to be potentially old. So it's not clear how you keep those keys around in order to verify the signatures there.
Yeah, I think there's some bookkeeping. I'm not tremendously worried about old stuff. So old stuff hanging around is inherent in the single signature variant here, right? So B double prime and B triple prime no longer appear in the tree. They're stale. They've been overwritten. So this approach inherently keeps some old stuff around. It's kind of the cost, but I don't think that undermines the security of the protocol.
Well, I mean, at the end of the day, you need to be able to verify a signature. So if you have rotating signature keys, you also need to keep around the old ones in order to verify old signatures.
Possibly. I think we need to whiteboard this a little bit to understand precisely what we're talking about. But yeah. So this is more of a announcement of intent. I think the tree signing stuff indicates there's a need for signed stuff in the leaves of the tree. Client init keys are signed, and they give us an opening to rotating signing keys in the future because you could envision having an update where you replace not only the DH key but also the signing key. And as long as that's been recertified by the authentication service, you're okay. You're the same. You can verify it's the same user. So this is very preliminary stuff. Keep an eye out in the future. This is more of a highlight. So looking at implementers in the room, this is something we discussed at the interim. It would be good to get a little bit more motion on this. So I put on the list, I was able to extract some data from WebEx Teams about how groups are actually used. So one of the questions we've had about this protocol is like, what does the overhead look like? What does the cost look like in the context of actual groups? Like what is the distribution of sizes of groups? How often do people join and leave? So what I've done in the WebEx Teams context, because that's what I happen to have access to, is I've gotten some ways to generate, I've called it anecdata here because it's only what I as a user of the system can see. So it's a little bit special. It's not global across the system. But I've gotten a way to extract these this is what I've called a transcript of the group's lifetime. So it's a bunch of events, add, remove message events with an indication of who in the group did it, by index. No identifying information, but who in the group did it and kind of how often that occurred. And that seems like it's a useful input to running basically a simulator of what MLS would have to do here. And so you can simulate all of the crypto operations that the various participants in the group would need to do. So I think that there's a question here. I think it would be useful to get some of this to build confidence in the protocol, to do some of this simulation and answer questions like, what is the impact of doing commits at different times? If you, like, for example, always update on when you're first added, how full does that keep the tree? What does sparsity look like? So this is kind of an invitation to researchers and other operators of messaging services to say, can we get some more data here? And would anyone like to volunteer to run some simulations and do some data analysis? Because I think that would be useful in terms of building confidence in this protocol. So I don't know if the Google folks or Wire folks have any ability to get this data or share this data, but this is kind of this seems like a very highly abstracted form, which may be extractable, but is also useful for evaluating the protocol.
So Calvin from Google, could try to get it, no guarantees. Depends on the privacy and how we can, apps. I think Emad said last time he tried to get some data, but he doesn't come through with it. So I have to check with him.
Okay.
See where it's at.
Felix Honda, Facebook. I used to work on messaging. If you want to send me an email, I can definitely forward it to the right folks. But it's probably unlikely that we'll be able to share this.
Do you think is there maybe a more limited form that would have a more likelihood of success?
That is a good question. I can investigate.
Yeah, and for instance, you can envision just getting summary statistics like the distribution of group sizes or the inter-arrival rate of adds and leaves.
Yeah.
Yeah, so I'll send you an email as a follow-up. All right, and I think that's the last thing I had. Yeah, it's the last slide.
All right. So the other exciting news is we're having yet another interim in January. We're going to do it on the 11th and 12th in New York City. Did I get that right?
That's right after real world.
Right after Real World Crypto. So basically, we will get all the implementers and a lot of the academic community in the same place. I will submit the interim request for Ben shortly. Beyond that, be on the lookout for stuff on the mailing lists. Thank you very much. And thanks for getting done 10 minutes early.
If somebody has the blue sheets, we would like to collect them.
Another blue sheet trick